Okay, we can start. Hello, my name is Genia, and today we're going to talk about mobility of virtual machines in Kubernetes clusters, and especially about storage live migration and cross-cluster live migration for your virtual machines. We will cover how and why and features and requirements, and we will see a short demo. First of all, how many of you are familiar with KubeVirt itself? Like, do you know what KubeVirt does? Yeah, most of you. Okay, for those who don't know, KubeVirt, like, we run virtual machines in Kubernetes. And how many of you are familiar with live migration when we talk about KubeVirt? Okay, okay, so let me explain. Usually when we talk about live migration in KubeVirt, we mean a compute live migration. It's been there like since the beginning of KubeVirt, and it means that your virtual machine remains running while your virtual machine instance is moving from one node to another. And one of the requirements for this type of live migration is that your VM must use a shared storage. Means your VM's PVCs need to have read-write-many access mode, because at some point you need to have two Virt launcher pods that will be connected to the same PVC. So, and in this case we have one VMI, virtual machine instance, whose job is to synchronize between the source and the target, and this VMI serves as the point of truth for the synchronization. Remember this, you will need this information in 5 minutes. But I'm from the storage team, and we were like, everyone talks about live migration, but we were not invited to the party, and so we invited ourselves, and we heard feedback from from users who say, I want to live migrate my VM, but it uses some old storage with read-write-once file system PVCs, but my VMs are so great, I want to keep them running. And we say, okay, we may have a solution for you. So we said we can do storage live migration. So when we do storage live migration, your VMI still moves from one node to another, but also your disk data needs to be copied from source to the target. So it means we removed, and it means that there is no point in time when you have two pods who need to use the same PVC. So it means that even if your VM has simple storage with read-write-once access mode, it still can be live migrated to another node, and this will work for any combination of volume mode and access mode. So you may have a local storage with read-write-once file system, and then you want to upgrade the storage, like you buy a new storage, you install it, and it has like read-write-many block. You can migrate your VMs to use this new storage. So like this is helpful like when you upgrade your infrastructure, when you want to rebalance your storage, and when you want to retire your legacy storage solutions and adopt new ones. Now let me show you how would you do it, like if you want to storage live migrate one VM. So we have a user guide, you can find instructions there, but in general you would need to update your KubeVirt CR. You may also need to add the feature gate for disk expansion. If you're using KubeVirt, most likely you already have it, because like there's very few things you can do without it. So, but these things are related to storage live migration, like rollout strategy and workload update methods. So you update your KubeVirt, you create your destination data volume with the blank source and your target storage class name. you cannot specify the storage class name. We will use just your whatever you have default in the cluster. And then you need to update your VM spec. Just add the update volume strategy and new PVCs or data volumes names. Once you updated your VM spec, you will see that virtual machine instance migration resource had created, and your VM is started migrating. So, and in the end, you will see that your VMI moved to another node, and you have your new PVC, and your VM is using this new PVC. And we still keep in the old PVC. You can go and clean it up like manually. And so this was about migrating one VM. Like if you want to do it in bulk, we already have an orchestrator for that. It's available in KubeVirt. It's super fresh from the oven. You just need to install the KubeVirt migration operator. It will install the controller and all the CRDs you need. And you would just need to create a migration plan. In this case, I'm showing you a multi-namespace migration plan. So you can list the namespaces and the virtual machines inside those namespaces and the disks that you want to migrate. In the part of where destination PVC, you can specify the storage class name, volume mode, access mode, whatever you want, and just create the migration resource. Once you create the migration resource, the migration will start, and the migration resource will report the progress, and the plan also will show you how is it going. Okay, so we migrated our VMs to the new storage. But then it looked too simple. And we got feedback from the users who say, yeah, upgrading the storage is nice, but what if I want to move my VM to another cluster? And we are like, okay, moving to another cluster sounds like a challenge, but sounds like a very nice one and interesting one to solve. So it generally can help you with your upgrades, with your load balancing, with infrastructure consolidation. If you have multi-cluster environment, you can just easily move your VMs between the clusters. And one of use cases, like the most painful use cases, is if you have a single node cluster and you want to keep your VMs running. Without cross-cluster live migration, you wouldn't be able to do any maintenance on this single node cluster without stopping the VM. So today, with cross-cluster live migration, you can move your VM to another cluster, do whatever maintenance you want to do in your source cluster, and move it back or keep it in the new cluster. Like so. Life becomes easier, and you have more options of how to keep your VMs running. So this was the why. And now let's talk about the essence of the cross-cluster live migration. So it appears that cross-cluster live migration is just a variation of storage live migration. Let me explain why. Like, you still need to move your VMI from one node to another. You still need to move your storage from the source to the target. And in this case, it just appears that your target node resides in another cluster. So we say, okay, we are simple storage guys. We see storage live migration everywhere. Let's do it across the clusters. So how we did it? libvirt and QEMU give you solutions to live migrate your compute and storage. And this is not new, and this is already used in different virtualization solutions like OpenStack, and it's used for compute live migration. But in our case, we had a problem. We didn't. We need to somehow synchronize between the source and the target, and the source and the target are not even in one cluster. Because you remember when we talk about compute live migration, you have VMI, which is one VMI, and one VMI can do it all. It can access the source, the target, and do the synchronization. So what we did, like essentially the innovation bits that we added to the Kubernetes is the synchronization controller, which is now responsible for synchronizing between the source and the target. So we invented the decentralized live migration. That's how we called it. So with the decentralized live migration, you now have two VMIs, you have two virtual machine instance migrations, and you have a sync controller that serves as a source of truth between the source and destination VMI. And so generally you need to, and very important part of this is that your virt handlers need to be connected through migration network, and your sync controllers need to be able to talk to each other through migration network. So now let's see how would we do it if we want to migrate our VM. Again, we have a user guide. You can find detailed steps there. But then what we need to do. In KubeVirt CR, we need to activate the decentralized live migration feature gate. Once you activate this feature gate, you see that your virt synchronization controller pods appear in your cluster, and you need to wait for them to start running. And another thing, you need to specify the migration network. Network deserves a talk on itself, and this talk happened here an hour ago. Yeah, Miguel is here. He explained it. He explained how you can do it. So once you update the migration network, you will see that your virt handler pods will restart, and now they will know that they need to use this network for communication with other virt handler pods when they for like migration itself. Okay, and then we would go to the target cluster and create target virtual machine resource. The best way would be to copy the source VM spec, to replace the network and disks and config maps and secrets, whatever you need, so that it will match what you have in your target cluster. Then the most important part is to set the run strategy is wait as receiver. Wait as receiver is a special run strategy, which means that once you create your VM, it does not start running. It creates VM, it creates VMI, but it's waiting for the migration to start and waiting to receive the data. And we also need to add the annotation for restore run strategy. So once your migration will be finished, you will get the desired run strategy, like a normal run strategy of a VM. It's like it could be always rerun on failure or manual. Next step. We are still in the target cluster, and in the target cluster we would need to create virtual machine instance migration resource. This one looks pretty simple. like name, namespace, migration ID is whatever ID you want, VMI name, your target VMI name. Super easy. But now let's go to the source. Your source virtual machine instance migration needs to get like the same migration ID, the VMI name, and it needs to get the connect URL. So this is the address that this is the synchronization address for your virtual machine instance migration to communicate with the other virt handler pods in the target cluster. So you can get this synchronization address from two places. One is KubeVirt CR. You have a synchronization address in KubeVirt CR status, or another place. If you don't have access to KubeVirt CR, you can do it. You can look at it at the target VMIM, which we created one step back. So once we create it, it will get the synchronization address in its YAML. So you can take it from there. So it will be just IP address and the port, and you just need to copy it here. Okay, now requirements. Of course, your two clusters need to be somehow connected. It can be L2 or L3 network because your synchronization controllers need to communicate with each other somehow, and virt handlers need to communicate with each other. Also, your clusters, like source and target nodes need to have compatible node architectures and VM CPU models. It's required for every live migration, but for cross-cluster, it's like especially worth mentioning. And also, you need to create or make sure that your target cluster has all the resources that your VM requires. So if your VM uses like vGPU, make sure that you have it in the target. Or you can do an orchestrator who can do it for you. They actually have an orchestrator. I will talk a bit later about it. And another thing that you need to do is to make your clusters trust each other. So each of your clusters has a KubeVirt instance, and each KubeVirt instance has its own certificate authority. You need to exchange the certificates between the source and the target cluster, so they will exchange the data. You can find the info in the user guide of how to do it. Like, it's super easy. Yeah, every time we talk about security, it's super easy. Now, the limitations. We would not live migrate storage or cross-cluster disks that are shareable. And shareable, I'm not talking about read-write-many disks. I'm talking about read-write-many plus specially configured that this disk has several writers. Like, you can do it in KubeVirt. You need to like a special setup for it, but we cannot guarantee that we will keep your data consistent if you have multiple writers. Then we also do not support file systems devices. Do not be confused with the file system volume mode. It's not the same. It's different. It's like file system devices. It's devices that you list under like domain devices file system. Different thing. And also LAN disks, because we cannot guarantee that you have the same LANs in the target. And now let's see a little demo. See a short demo. It will not be as impressive as Miguel's demo. I'm not like sending pins, you know, those network guys, we send the packages, we receive the packages, we cannot like lose the packages. We are chill in storage, we just don't lose the data and no, okay, we are not so chill, but okay. So you can see on the left is my source cluster, on the target, on the left is my source cluster, on the right is my target cluster. We created virtual machine. It has a data volume. It now pulls image from a registry. It also has some networks. Like we are waiting for this to import. Okay. And we just connect to the console and we write some super simple file. Nothing special. Okay. Now we go to the target cluster. I already have a VM YAML prepared for this. So I create my target VM. You see that target VMI also created. It still has waiting for sync status. So it's just sitting there, doing nothing, like waiting. And you can see that I have this annotation for the restore run strategy, and my run strategy is wait as receiver. You want that? Okay. And you see that this data volume also got created, but it's not populated. It's still waiting for consumer. And we create the VMIM, sorry. And now we want to get the connect URL from the KubeVirt CR. And our source VMIM has this connect URL. So we created, and you see the migration started. You see the target VMIM started scheduling. Like the source VM is still running. Yeah, and migration succeeded. And we can check. You see, like now we connect to the console in the target cluster, and you see it didn't even ask us for password. So generally, you can watch your YouTube on the same VM, and it will be migrated across the clusters, and you wouldn't even notice. So. That's it with demo. Now let's see. And I talked about orchestrator. There is orchestrator for bulk cross-cluster migrations. It's available and open source. It's called Forklift, and it also has nice UI. You can try it. And then the credits for developing this feature go to Alice, Alexander Wells, Alex Kaleniuk, Sam Lucidi, And thanks to Miguel for demo setup, and thanks to KubeVirt community for reviews and acceptance. And thank you for watching it.